Hello again. Let's get on with a lecture on graph analysis. So this should be a fairly fast lecture. Mostly what we're looking at today is this idea of modeling and looking at data. But basically, it's just going to be identifying real world scenarios and trying to figure out what types of functions might apply to explain those real world scenarios. So the first thing I'll say before we get into anything is that this material that we'll talk about today can get a lot more complicated, and by a lot I mean really more than you could possibly even think of. So basically, when I use this sort of very brief statement to say we can look at a real world scenario and figure out what type of function, maybe linear, parabolic, exponential, or something like that. When we look at those types of things and try and use those to describe a real world situation, that can get very, very complicated. That can get very tough, just because these real world scenarios can be very complicated. We'll look primarily at just simple examples, but I just want to point that out, that this stuff can get very, very complex. So looking right off the bat, let's talk about this idea of data. So let's say you're doing an experiment, or you're watching some real world phenomenon. You're watching a baseball being thrown. You're watching a car being driven. You're looking at economics. Really anything you can think of. You might take data on what's going on. You might record what's actually happening, as in each of these scenarios. And so when you're looking at this data here, what you could do is you could try and graph that data. You could look at it and try and convince yourself, hey, this sort of, the trend here is that this is linear, or it's parabolic, or it's exponential, or maybe some other type of function that we've talked about, or maybe even a combination of them. And so this can get fairly complex. Let's go ahead and talk about this idea of modeling. I've said that word just a little bit. So if we're looking at data, so we're looking at sort of things that we've observed in the real world. You can use what we'll call a model to approximate the values of that data. So you might have the actual data points. You might have, let's say you're running, and you might have the actual speed that you are running at. But if you wanted to approximate that, you could model it by saying, hey, my speed increases linearly. And then you can use a linear function to sort of approximate what your speed might be in different scenarios. So let's go ahead and look at an example here. Let's say that we throw a ball up in the air. So we take a ball and we just throw it, maybe with a little bit of an angle, but we throw it up in the air. You would expect that ball to just go up and reach a peak and stop right at the top, and then come right back down. It'll come down and it'll hit the ground. And so if we were to try and model this scenario, if we were trying to explain to someone how this ball sort of moves in midair, you would say that this looks like a parabola. It looks parabolic, right? And so saying that this looks parabolic is helpful, because this gives someone who's maybe not observing this ball being thrown, it gives them the sense that, okay, this ball is going to follow the shape of a parabola. So maybe if they throw a ball under different conditions, maybe it's windy, maybe they're at a higher elevation, so there's maybe less air resistance, or a whole plethora of scenarios that you could consider. But they know that in general this ball is going to follow this parabolic shape. This might seem pretty simple. You're like, yeah, if you throw a ball, it's going to go up and then it's going to come back down. But really, this can be extended to even more complicated scenarios, and just understanding the basic idea that this scenario is parabolic is huge. And it's huge if you're trying to do an experiment of this. Maybe you change the type of ball that you throw. Maybe it's a bowling ball versus a ping pong ball, and that ping pong ball is going to have a lot more air resistance, than the bowling ball will. And so you might have these different scenarios, but you know that generally you can figure out what the shape of this path is by just starting off knowing that it's basically parabolic, that it's sort of at its core parabolic. Let's go ahead and look at another example. And here, this one, you could kind of go with two different answers here. Right off the bat, when I look at this to me looks fairly parabolic. It starts going up and then it starts going down here. And if I were to continue this, maybe we expect it to go this way. Or if even if I continue to, obviously the graph doesn't go over here, but based on this trend, it might look like it keeps going here. So you might be able to convince yourself or convince someone else that your graph looks like this. And that to me looks parabolic. And so I'll go ahead and write that down. That would be a perfectly acceptable answer. Again, remember, we're just sort of guessing at what we think this function might be. You know, when we're looking at the speed of a car and the miles per gallon that it gets. But here's something that you could also say. You could also answer, let's go ahead. I'm going to change the color here just to make sure my colors actually match up. So we have in the red here, we have this parabolic scenario right there. But you could also say that, what if I split this up? What if I just said that this was a line here? And then maybe if I'm talking about it being a piecewise function, I could change the line right there. This to me looks like it does a pretty good job of sort of modeling this graph. And really, I could convince you of this, just because we don't have a whole lot of data. I could convince you that this is either parabolic or that it's linear, maybe with a piecewise break in it. And so you could be convinced of either thing here, whether you were to say, hey, this is parabolic, you know, in the red, or linear in that blue, but with a break there. And that might be hard to figure out. Maybe we need to take more data. Maybe we need to look at different cars. Maybe we need to look at more speeds. Like I said, the last data point here looks like it's at 30 miles per hour. Maybe we need to drive slower. The last data point here looks like it's at about 75 miles an hour. Maybe we need to drive faster and figure out what this actually looks like. Change the car, change the incline of the road that you're driving on, change the tires that are being used, change anything you can think of. And if you start to see more and more that the shape looks parabolic every single time in all of these scenarios, then you could say, hey, this is parabolic. But if it continues to look like this very sharp, you know, sort of jagged edge, maybe, then you could say, hey, it's linear and it's a piecewise function. So I would accept either answer here. It really just depends on how you can convince me that it's one of those answers. Last example here. So this is going to be iPhone sales from several years back, and these are sales in the millions per year. So you can see in 2007 we started off at 1.4 million, and then in 2012 we started off at 125 million. And a lot of students here, they'll say, hey, this looks linear to me, because you can kind of draw a straight line and it basically follows what's going on there. But here's my argument. If I try and start drawing a straight line, eventually it doesn't really meet that height right here. There's sort of a gap in that height. And so you might then counter that by saying, well, what if we make the line a little bit steeper? What if we do like that? Well, then the problem is that you're not really meeting that height in any of these. And then even then you might be able to counter that and say, well, you could probably draw this kind of more in the middle and you could get it right there, or maybe even a little bit better and you get it there. But the problem is that really, no matter what line you draw here, it doesn't really match up with the data. It's not a good approximation for it. If I were to draw this red line and then you ask someone, hey, based on the red line, what was my number of sales in 2010? Well, here in 2010, there was actually 40, but based on my red line, it looks almost like there's something like 60 maybe. And so that's not really a good estimate at all. And so a line here doesn't really work. Let's go ahead and get rid of all that right there. This to me looks more exponential. And it looks exponential because it's growing at a faster and faster rate each year. You would presume that this would go up and up and up. And I don't actually have the data off the top of my head for later years, but I do know that it increases a lot more And so this actually does look exponential here, where it starts off really small. The growth from year to year isn't that much in the beginning, but then as you go from 2010 and onward, it starts to grow a lot more. And in most of these years, other than this first year, the first year is a big jump because the iPhone got very popular in 2008. But from 2008 to 2009, I see a very, very, very rough doubling. It's not quite double, but it's roughly double. And then I see that again, it's roughly double from 20 to 40. And then again, not quite doubling from 2010 to 2011, but close enough. And then again, not quite doubling, but close enough between 2011 and 2012. And that's exactly characteristic of an exponential function, where you're seeing something double year after year. And again, maybe not quite double, but I'll use that word just because it's easier to say. So, you're seeing these iPhone sales basically double year by year, and that's exactly characteristic of an exponential function. And so we'll say exponential. So if we were trying to guess at how many iPhone sales there were in 2013, let's go ahead and sort of put a graph right in here. If we were trying to guess in 2013, I might say something, heck, maybe even a little higher, right? And we've kind of said this idea of maybe doubling, but not quite doubling. I don't know, maybe just a very, very rough guess, just putting 200 right in there might be an appropriate guess. But that's exactly what we've done. We've used the fact that we can look at this graph and we can say, hey, this looks exponential to me. Let's take that information. Let's guess what the iPhone sales in 2013 will be based on that info. If this were linear, then we would see a much different result. We wouldn't get quite up to that 200 guess that we're seeing with this exponential graph. So that's kind of the idea here of looking at data and using that data to model it and figure out what type of function would actually be good to, sort of append to this data and say, hey, this type of function, linear, parabolic, exponential, that type of function describes this data. We'll go ahead and call that for the lecture, and I'll see you next time.